hand over to... it's not Thomas. You. Okay. I see.
So I need to download this, go to the website.
Okay.
Website.
You.
This one, yeah.
Which one?
Do I have no bugs there?
Yeah.
And if we refresh this page, because I just uploaded it.
Sorry, I did. I don't thought my class.
Can I play this from here, or is there a presentation? No.
Not sure. I think it's better to.
Yes. This.
Yeah. Okay.
This one works?
Yes.
Perfect. Yes, I'm not Thomas Rod. I'm Fredrik Bolmsten, so I will do this presentation instead. So I'm the group leader for scientific information management systems at ESS, and I'm going to try to explain kind of the envisioned pipeline we have for ESS. ESS is, as you know, not operational, but we are slowly but surely getting there. So what we're aiming is to have a common data pipeline for all of the different instruments, and that data pipeline should also then support making data fair. And already from the beginning of ESS, when ESS was conceived, there was this realization that software and compute will be a big part in the future. So this was already outlined in the technical report that this is going to be a big part, and significant investments were therefore also made into this. And that was the creation of the Data Management and Software Center where I reside. So the idea is that we have this center of people. We're roughly 40 people. It's going to grow to even 60 people in the near future. And the idea is to support the user from the very, very beginning to the end. So from the idea to publication step. And to do that, we need to develop a whole range of software and systems that need to interact together. So we'll talk about that. And of course, the idea of this is to maximize the scientific impact from the experiments and reducing the barrier to entry. I think I saw a report from ILL a while ago, and where they had kind of plotted out the time from an experiment until that actually produced a publication, and that time was steadily growing with time. So this is kind of the attempt to try to reduce that in some way, or at least to stop that. And there's probably good reason why it's taking longer and longer. Experiments are becoming more and more complex. So there needs to be more help for the user to be able to handle this. So to be able to handle this, we have the DMSC organization. I just will say a couple of words because I think it's interesting from an organizational standpoint. We're sitting in the Science Directorate. And the first group that you will see here is the instrument data scientist. And this might be a bit of a unique role at facilities, I don't know. But this is not instrument scientist, this is instrument data scientist. That means that they are embedded into the instrument teams, but they are residing into the data management and software center. So it's their job to make sure that the data that is collected at the instrument can kind of flow through this data pipeline. And they are kind of the advocate for the instrument to us. So there's a lot of pressure on them to also guide and steer, because we have the main data pipeline, but of course that will need to be customized for each of the instruments. And then we have a couple of different groups. We have my group. We are doing different information management systems. We have a data reduction group. We have an infrastructure group. And we have a experiment control and data creation group. And if we look at those different groups and we look at kind of the data pipeline that we're envisioning, you can kind of see them coming into the different places. And I will go through this step by step, and I will kind of show you what software we have developed and how that also then will hopefully enable more fair data that is coming out of these ones. So let's get started. First part will be the user office system. We developed our own user office system from scratch, and we have been lucky enough to have some really good collaborators on this, SDFC and Eli. recently. And what we have done in this system is that virtually nothing is hard-coded. It's completely configurable, and it's very dynamic. And there's good reasons for this. Both, one reason here is that we can then have multiple facilities joining us and working on this software, but also we can really ask the key questions for the user in a proposal. So they don't need to answer redundant questions. And this will be one of the key points where we are starting to collect the metadata that will enable us to have fair data. So here we of course have things like the title and abstract of a proposal, but we also collect the sample information here, and that will trickle down then into the systems downstream. And it also triggers a bunch of other systems to do their thing. So it has real-time kind of communications with message brokers, etc. So one of the things, after we have all the reviews, scheduling, all of those things done, one of the things that this will trigger is, of course, standard proposal folder and file creation. So this is something, after a proposal has gotten accepted, all of these folders will be created. We will create all the different groups for these people, and we can then start collecting data. So this will be there from the start. So if we go a bit more into a deep dive of kind of the high-level overview of the infrastructure that we have here, we have our different detectors. And if we look here on the top left, the data that is coming out of them, we have our readout master module, and then we have something called an event formation unit, which essentially just takes the data coming out, creates a XY coordinate and puts a timestamp on it. All of this is streamed into our Kafka cluster, so we do streaming. On the other side of things, we have our slits, shopper samples, and sample environment that we have communication there with the control system. We use Epics, and all of that data is also forwarded into Kafka. We are using Nikos to kind of steer this the experiment, and those signals are also sent into Kafka. And what you can't see here is actually that Nikos is also getting information from other sources like the user office. So then we have Nikos sending a start and stop for data collection, and that goes into a file writer, and that actually writes the file down to storage. So this is the envisioned structure for all of the different instruments. If we look at Nikos, one of the things then to enable fair data is that integration with the user office, for instance. So users here will be able to select the proposal that they have. They will see some information regarding that, and they will see the samples that they have declared. And we are quite strict regarding this. There is a possibility here to add new samples and to mutate some of the information. But as this is also going through our experiment safety review, we can kind of enforce this, that users should not, in theory, be able to then bring other things than they actually have said to us. But there's some ability here to add that. And all of this will then be streamed down into this Kafka and then be picked up and written both into the file, but also picked up into the metadata catalog downstream. Then to support this and to do the data reduction, we will then have these different, when we have the data, we have our skip, which is a Python package that is developed by our in-house team, which is essentially kind of a better, more enabling X-array and adding extra features to that, which is more in line with kind of when you have collecting neutron data. And we are very Python heavy at ESS. The idea here is that users should be able to use Python either in a Jupyter notebook, or we launch a VM, or on their own computer to be able to do a lot of these things. Other than skip, we also have easy science. So Easy Science is essentially also Python-based, but it's a wrapper for all of these other projects. So there's multiple different ways of doing data analysis, and being able to kind of have one unified look and feel for our program, but not reinventing the wheel everywhere is quite important. So here the team has worked very hard to make a kind of easy-to-use user experience for users that want to do their data analysis. There's, of course, other ways that users are free to do whatever they want, and we launch a VM in Visa for them where they have additional tools if it comes to that. And then we have the fair data management side. SciCat has been mentioned multiple times here, so I'm not going to say too much regarding that. I mean, there's a strong collaboration regarding this, and we are also committed to this, making data public after 3 years. The intention is, as other facilities, to mint the DOI very early on, and then to enhance that and let the user be able to do their data management through SciCat. So SciCat kind of sits key in this in the IT infrastructure. Yeah. Wrapping up, the idea, when we have all of this, we will send this into the Panos catalog. So I want to make a bit of, so people know that this exists, and we also have gotten a grant recently to enhance it even further. So there is active development going on here. It's not a project that ended with Panos. It's now going to be developed even further down the line to be able to enable this. And the current status we have now is, of course, we are not online, but we have this pipeline. It has been proven, but now the devil's in the details. So we are rolling it out to the first tranche 1 instruments, and then the idea to continue on. But we will, of course, find a lot of things when we're doing this. Yeah, so that was what I had. Thank you.
Very on time. Thank you very much, Fredrik, for this clear and exhaustive presentation of the future of SS. Is there any question? So if not, I see one.
Sure. Really interested in SCIP. Haven't had a chance to explore it too much, but I wonder if you could comment on directions, roadmap, status of that project specifically anymore?
I am the wrong person to do that.
Okay, no worries.
You're in contact with the right person to comment on that. Yeah.
Sounds good.
Okay, so then I think we can thank again all the presenters, and we're done with the session. I think we are ready to go to the canteen. Thank you.